Lighting a garden at night is not just about safety, it is also about atmosphere. The glow along a walkway, the soft illumination of trees, and the sparkle of lamps among flowers transform an outdoor space into something magical. But traditional garden lighting depends on electricity, wiring, or disposable batteries. These cost money, waste energy, and limit creativity. What if we could light our paths with lamps powered by magnetic resonance, operating as Overunity systems that draw from natural forces instead of the grid? That is the vision of Overunity Garden Lighting. Why garden lighting matters. Garden lights serve practical and aesthetic roles. They guide footsteps, deter intruders, and highlight features of landscaping. Yet most solutions rely on low-voltage electric cables buried underground or on solar lamps that dim after a few cloudy days. Both systems tie us back to limited energy supplies. For free energy experimenters, this feels like an unnecessary compromise. If magnetic resonance lamps can be built to operate independently, a garden can glow all night without paying for power. The principle of magnetic resonance. Magnetic resonance is a phenomenon where energy transfers efficiently between coils tuned to the same frequency. Imagine two tuning forks vibrating together. One is struck, and the other begins to sing. Similarly, when one coil is energized with alternating current, a second coil tuned to its frequency can receive energy wirelessly. This principle already powers wireless charging pads for phones, but experimenters believe it can be extended to free energy systems. By using permanent magnets, resonant circuits, and clever feedback loops, energy may be recycled and amplified in ways that appear to surpass traditional limits. In a garden lamp, this means light without batteries or hardwired connections. The concept of Overunity lighting. Overunity lighting does not necessarily mean creating energy from nothing. Instead, it means tapping into energy sources that are often ignored. Ambient electromagnetic fields, resonance effects, or stored energy in magnetic fields. By designing lamps that resonate with a central transmitter or with natural frequencies, the system can stay lit with minimal input. Imagine a central pole in your garden containing a resonant transmitter coil powered by a small free energy prototype. Around the path, smaller lamps each contain receiver coils tuned to the same frequency. When the transmitter vibrates, the receivers light up, glowing without direct wiring. That is the promise of magnetic resonance garden lighting. Building the magnetic resonance lamp. Each lamp consists of several key parts. Resonant coil, a copper coil tuned to the frequency of the transmitter. Magnet assembly, permanent magnets arranged to enhance field interactions and support oscillation. Circuit elements, capacitors, and diodes that stabilize resonance and direct energy flow. Light source, usually LEDs, which require very little power but shine brightly. Protective housing, weatherproof enclosures that keep components safe outdoors. Together, these create a lamp that glows whenever the central system resonates. No wires, no batteries, only the invisible dance of magnetic fields. The central resonance hub. The heart of the system is the hub that excites the coils. It could be a permanent magnet rotor that pulses current into a transmitter coil. It could be a radiant energy circuit that captures ambient energy and feeds it into resonance. The hub does not need to be large. Even a small transmitter can power many receivers if tuned correctly. Placed at one end of the garden or disguised as a decorative post, the hub sends energy invisibly through the air. Each lamp along the path is awakened when its coil resonates with the hub, producing light exactly where it is needed. Safety and practical design. Because this system operates outdoors, safety is crucial. Resonant fields should be strong enough to light lamps, but not interfere with radios, phones, or medical devices. Lamps must be sealed against rain and moisture. Magnets must be secured against corrosion. Paths often experience foot traffic, so housings should be strong enough to survive kicks, bumps, or even being run over by garden tools. Using polycarbonate covers, stainless steel mounts, and silicone gaskets ensures the lamps last for years. The beauty of wireless illumination. Imagine walking through your garden at night. You see no wires, no solar panels, no batteries. Instead, the path glows with clean, even light from elegant lamps that simply stand in place. The central hub hums silently, hidden among plants. The effect is magical, futuristic, and yet completely practical. This experience is not limited to gardens. Pathways in parks, courtyards, and rural communities could all benefit from wireless Overunity lamps. The elegance lies not only in appearance but in the independence from conventional power. Engaging your curiosity, let me pause here and ask you something. If you could walk outside tonight and see your garden glowing from lamps powered only by magnetic resonance, how would you feel? Would it not feel like living in the future? Would it not feel like proving that free energy is real, not only in theory but in practice? That is why experimenters chase this vision. It is not just about light, it is about freedom, testing and experimentation. Like all free energy ideas, magnetic resonance lamps require careful testing. Start with a single transmitter and receiver pair. Adjust coil size, winding number, and capacitor values until resonance is achieved. Watch for the lamp to glow brighter with minimal input. Once the principle is proven, add more receivers along a path. Check how far they can be placed from the transmitter before the light fades. Experiment with coil shapes circular, spiral, or cylindrical. Each design interacts with fields differently. Record all results carefully, because every experiment adds to collective knowledge. Efficiency versus Overunity. Critics often ask, is it really Overunity or just efficient wireless transfer? The answer may depend on perspective. Even if no extra energy is created, the ability to light many lamps from one transmitter with minimal input is valuable. Efficiency itself feels like Overunity compared to wasteful grid-powered systems. Some experimenters claim that resonance draws in ambient energy, boosting the system beyond conventional expectations. Whether or not this is true, the practical result is the same bright lamps with minimal power input. For the experimenter, the line between efficiency and Overunity may blur, replaced by the excitement of discovery. Potential applications. While garden paths are an attractive use, the concept extends much further. Farms could use wireless lamps to light fields. Remote villages could illuminate roads without wiring infrastructure. Emergency zones could deploy instant lighting with a single hub and portable lamps. Even indoor environments could benefit, reducing the need for complex cabling. The scalability of resonance makes it powerful. One hub can power a few lamps or many, depending on design. As prototypes improve, entire communities could one day glow from free energy resonance networks. Challenges ahead. No experiment is without obstacles. Resonant coupling weakens with distance, limiting lamp placement. Weather may affect performance. Construction must be precise, since resonance requires fine-tuning. And while permanent magnets are strong, they can lose strength if overheated. Yet none of these challenges are insurmountable. With creativity and persistence, solutions emerge. Multiple hubs can extend range. Better materials improve durability. Automated tuning circuits can adjust resonance in real time. Each challenge is simply another step in the journey. The emotional side of innovation. There is something deeply inspiring about lighting a dark path with energy that seems to come from nowhere. It touches the imagination, the same way fire first amazed our ancestors. Free energy resonates not only in circuits but in human spirit. The glow of magnetic resonance lamps is not just photons on a path, it is hope made visible. Overunity Garden Lighting with magnetic resonance lamps is more than a technical experiment. It is a vision of independence, beauty, and sustainability. By combining permanent magnets, resonant coils, and free energy principles, we can light our paths without wires, without batteries, and without cost. The journey will take time, patience, and many experiments. But each glowing lamp is a step closer to a future where free energy transforms not only laboratories but everyday life. Imagine your garden, your park, your street shining with lights that answer only to nature's hidden forces. That is the promise of Overunity lighting. And it is a promise worth chasing.